We're going to look at the Testo thermal cameras now to show some of the benefits they can bring to a heating engineer. So we've got some applications here with a radiator and then trying to track some pipe work, maybe leading from that radiator. So this is really highlighting how a camera can help you understand what's going on within the building from a heating point of view. Maybe you've gone into a property, you're trying to assess, do the radiators need power flush, for example? Are they sludged up? But also maybe just tracking that pipework to and from a radiator, which can be guesswork if you haven't got a thermal camera. So we've got the Testo camera here, all powered up. Just remove the lens cap. So straight away we're just going to turn and look at the radiator in more detail. And straight away we can see from the image here a good consistent colour across the radiator, indicating that this really doesn't have an issue too much with either sludging or air at the top of the radiator. And what we can actually see at the bottom here from the upstands from the radiator going down behind the wall, we can see the trace of the pipework. And in fact, if I move the camera away from the radiator, we can then see the pipework is actually tracking up the side. And if I move the camera up and follow the pipework, you can very, very clearly see we can track it all the way up the walling here, right the way up and into the ceiling itself. You're probably wondering why the pipework appears much brighter here. If I bring the camera down, we suddenly lose that brightness. That's because the camera at the moment is also scaling on temperature range. So because the radiator is the hottest object, it's automatically scaling to that as being the main temperature range. But if I bring the camera away, and what I'm going to do now is just a little trick. I'm going to put the camera into manual mode. What I'm going to do now is actually just focus the temperature range purely on the pipework. And now we can clearly see as we bring the camera down, it shows the pipework much more dominant going to the bottom of the radiator. So we can see there really clearly how a thermal camera can aid you from understanding what's happening within the heating system in a building. One thing about the Testo cameras and thermal cameras in general is, don't forget, you've got the option to actually select different colour palettes. We apply the colour palettes to help us as humans understand what the camera is telling us from a perspective of apparent surface temperature. So as an example, we've got the camera here set in a very popular palette, which is iron. It tends to give very, very high contrast and very clear images, particularly on the sort of temperature ranges we're talking about here. Using the Testo camera, just literally I can select different palettes on the fly just by selecting using the up and down key functionality here. Grayscale as a palette will often be very aware of through a lot of the police camera action type videos you see on TV and on YouTube. And if we go back to the iron bow, and this is interesting, we can actually see this as a radiator now that's been obviously drained down or started to heat up, because all the temperature that we saw just now has disappeared. We've just got a little bit of temperature coming into the radiator, so this is actually warming up by the looks of it. So we can see this live now as the water is coming in from the hot upstand here. It's going up and filling the radiator. So this is really good timing now. We're actually going to see live the radiator getting warmer and warmer. You can see the temperature now from the top of the radiator is starting to come down. It's a hot area at the top. I'll just move the temperature marker up. We're getting around about 30 degrees, 31 degrees showing at the top of the radiator. First is around about 17.5 degrees, but you can clearly see now the hot water coming in, going through the radiator, starting to fill the radiator up, and we're getting a much more even temperature across the radiator itself. And again, if I try the different palettes, you see with the palettes it reveals subtly different information every time. And that's a really great live demonstration there. You can see how a radiator, if it was blocked at the bottom, you'd have a permanently cold area of sludge, and that will be very, very clear and very visual with the camera. Just going to show you something more with the Testo thermal camera. So here we've got an application where we've got a radiator and the pipework we believe is running under some floorboards. So this is an indication now how we're going to be able to track the pipework coming from the radiator. It's a little bit problematic because the pipework here isn't interscreed, it's actually in an air gap between the joists. But we're just going to show you what you can see with the thermal camera in this sort of application. Because the radiator is such a dominant hot object, it's nearly 73 degrees apparent surface temperature, all the pipework coming away from the radiator isn't particularly visible until I move the camera away from the radiator, and then the pipework suddenly becomes visible. And in fact, if I turn around now, I can see the pipework comes along behind the door, and is actually going across the hallway here and then down into the boiler. But it's only when I'm over the pipework we get to see the pipework route. But as soon as I bring the camera back to the radiator, we lose that pipework information. So this is a classic example where you'd need to change from manual scale to auto scale. So again, I'm going to go into the camera settings. I'm going to set the camera to manual scale. I'll manually lock the values. And now I can clearly see the pipework run across into the landing. When I come back, the pipework is visible all the way across, and then here the radiator has actually gone into what we call saturation. We know the radiator is hot, we're not too worried about that, but what it's done is lock into a temperature range where we can very clearly track that pipework back more or less all the way to the upstands of the radiator. So this is an application where we're showing you again, you can trace pipework even if there's an air gap. Ideally, pipework buried in screen will give you a much more linear edge to the image, a much sharper edge, but this is just really to show you can track pipework even in an air gap. Just going to show you another example of where you could use the camera. Very simply here, we're tracking some pipework back towards the boiler. Just want to simply see which is the flow and return circuit. Obviously very, very visual with the camera. We can see here which are the hotter circuits, which is your flow and which is your return back. You can use obviously the temperature measurement as well on the camera to look at the pipe temperature. But be aware, with copper pipework and thermal imaging cameras, you have an issue with regards to getting the camera to display an accurate value, because thermal imaging cameras rely on something called emissivity value. So you have to set the emissivity value of the material you're looking at to get the correct calculation from a temperature perspective. So where we would use the camera more is just to give us a guide as to which are the hotter pipes, which are the colder pipes. To get accurate temperature measurement, particularly on copper pipework, can be problematic with both thermal imaging cameras and infrared thermometers, so just something to bear in mind. So here we've got an interesting application. We've got the entrance to the building here. We know there's some pipework possibly behind this wall. If you didn't have a thermal imaging camera, again, how are you going to know where the pipework has been run from here around to the boiler? So we'll take the Testo camera. Very simply, you can see here, look straight away, we can see there's pipework, 2 runs coming down here as she gets to the bottom, and then is branching off here to the left. Basically goes round to the boiler itself, but very, very clear compared to what we can see visually with our human eye. All we see is the plasterwork of the wall, but the camera tells us a completely different story. It tells us we have actually got 2 bits of pipe coming down there from the heating circuit going off to the boiler. So a very simple way to understand where pipework is hidden behind walls, or if that was buried under the floor within screed, again you'd see very similar images.